Hello. So today I would like to discuss the different types of activation functions which can be used in neural network. Um, Actually, the major activation function which we have discussed till now is the sigmoid function. Okay, so activation functions. So the only activation function that we have discussed is the sigmoid function. Sigmoid of z is given by 1 by 1 plus e to the power minus z. Okay, and this looks like this function. If we plot this function, it looks like if this is z and this is sigmoid of z, this is a 1, then the way this function looks like is so now this out. Okay, so this is 0.5. This is activation function which is essentially suitable for regression problem, sorry, for classification problems. Okay, wherever you have two classes and you want to classify them, then this kind of then sigmoid function is more what to say, more suitable, and its results are always between 0 and 1. Okay? However, it can also be used for regression problems where you can compress the output values between 0 and 1. This can also be used for regression problems. Okay, but primarily it is used for classification problems. There are other activation functions which, depending on the situation, might perform better. For classification, there is another activation function which is used because it is having a balance. It is a more symmetric activation function, the tanh function. The tanh function, tanh z, it is given by e to the power minus z, sorry, e to the power z minus e to the power minus z divided by e to the power z plus e to the power minus z. This is a more symmetric function, and how it looks like, let's plot it. When you plot it, it looks like this is z, this is tan h z, and if this is your say 1, this is minus 1. The way this function looks like, let's try a dotted line here. Uh, Okay, so this is the tan h function. This is also suitable for mostly classification functions, where you can make all your negative results, minus one, and all your positive results plus one. So while making the labels, you need to label all your negative results minus one and all the positive results plus one, and then you can use the tan h. You can use the tan h activation function, and this will work. This might work better than logistic regression function or the sigmoid function earlier. Then another question which many people ask me is, we keep in machine learning, it seems like as if we keep talking about classification problems a lot, because most of the computer science related problems are more of classification oriented. But if you look at other applications in other areas, there are a lot of applications of linear regression. Okay, there is a lot of application where the output variable is not a 1 or 0 output, it's a continuous output. Okay, and that's where how can we leverage the power of neural networks in those situations. For that, we have two other activation functions which are used for regression problems, which are the first one is the ReLU function. Okay, ReLU Z. This is called the rectified linear unit, and its function is given by max of 0 comma z. Okay, so this is the linear this is the rectified linear output function, and the way it looks like is so whenever z is positive, this will take this value z. This is ReLU z. And whenever it is negative, let me draw it with a different color. Negative, it stays as 0. It stays 0. Okay, in the negative side it just stays 0. So this is your ReLU function. Whenever you have an output which is continuous variable, which is wherever you have wherever you think linear regression, you have to perform regression. Instead of having sigmoid output units, you can put ReLU output units. You can even put ReLU units in the hidden units if the problem is actually a regression problem. So you have to experiment which units perform better. Okay, and depending on what is the output desired, you can either choose to use ReLU units or choose sigmoid units, or use sigmoid in certain parts of the sigmoid or tanh in certain layers, and ReLU in certain other layers. Okay, so depending on the problem, you can experiment and see which units perform better. Okay, but ReLU units are definitely to be used in the output units wherever it's a linear regression problem. Okay, wherever it's not a regression problem, you can use ReLU units in the hidden layers, and the final layer you can put as a sigmoid or a tanh unit. Okay, there is another activation function which is also used, which is a little variant of the ReLU function. It is called the leaky ReLU. Okay, leaky ReLU. This is given by max of 0.01 z, comma z. Okay, so this function is it looks like, if you plot this function, this will look like. Okay, so this function will look something like this. Okay, so this has a finite value. This has a non-zero value in the negative side as well. While ReLU just has a positive, has only positive values on the positive side and zero values on the negative side. While leaky ReLU has a negative value on the negative side, but a very small negative. Its rise on the negative side is much smaller compared to its or slope on the negative side is much smaller than its slope on the positive side. Okay, so this is these are the four primary types of activation functions that can be used in your neural networks, and they can be they can be mixed and matched in different layers. So certain layers can have completely ReLU, some certain layers can have certain layers can be ReLU, certain layers can be leaky ReLU, certain layers can be sigmoid or tanh, depending on the situation. Okay, so this is what I wanted to discuss today. I will show you how this has to be implemented um, on the Python, in the Python code, and let me see if I can find time again to write a code to demonstrate this. But you can also try this in your in your own free time. So the basic idea is, wherever you had that command in my previous lecture, if you go, there was a where we build the model, the block in which we build the model. There is a command called activation is equal to tf. Activation is equal to tf dot nn dot sigmoid. Okay, so instead of sigmoid you can try here relu or tanh. Okay, applying leaky relu requires a little different command that I will cover when I demonstrate that later in a later video. Okay, so thank you for now. See you again.